So we're here at the example table, and in this video we're going to sketch the function 2 times the absolute value of 3 minus x plus 2. So let's start with something basic. So we'll start with the absolute value of x. This looks like this pointy guy here. Right? So it's just the line y equals x when x is positive, and it's the line y equals negative x when x is negative. So the first thing we want to do is change what's inside the absolute value to this 3 minus x. Now one thing to note, the absolute value of 3 minus x is the same thing as the absolute value of negative 1 times 3 minus x, right? Because when you take the absolute value, a negative doesn't matter. So if you multiply this whole thing by negative 1 inside the absolute value, it has no effect. But we can now rewrite this as the absolute value of x minus 3. Now there's no mathematical reason to do this. Absolute value of 3 minus x is the same as the absolute value of x minus 3. But I find this a little bit easier to look at than this. So that's why I do that here. So now we want to sketch the absolute value of x minus 3. Well, since the minus 3 is occurring within the absolute value symbol, we know that that's going to be a horizontal shift of 3 units. To figure out in which direction, it suffices to see where this pointy part of the graph goes, right? Where this guy meets here, where does this go? That point occurs whenever what's inside the absolute value is 0, right? This here, the absolute value of x, that's 0 when x is 0. So the point is at 0. What value of x do we need to plug in here to make it 0? Since it's x minus 3, we need to plug in x equals 3. So to graph the absolute value of x minus 3, we start with this absolute value graph and we shift it over. So the pointy part is now at 3. So we get something that looks like this. Right? So now we have this point, we can label this 3, 0. And we also now have a y-intercept up here, which is at 0, 3. So there's our graph of the absolute value of x minus 3. Now let's throw in this 2, and we'll start that on a clean sheet of paper. So to get 2 times the absolute value of x minus 3, well, we're going to start with the graph that we just had. And since we're not really worried about anything other than making a sketch, right? This doesn't have to be nicely to scale or anything like that. We can essentially draw the same picture. The only thing that changes when you multiply this by 2 is that you're stretching the y-axis. The positive part you're stretching up by a factor of 2, and the negative part you're stretching down by a factor of 2. Right? You're just pulling the y-axis in both directions. So this point here, this guy, is still 3, 0. Right? Points along the x-axis haven't changed. But now this thing, which used to be 0, 3, is now 0, 6 because of this 2. And that's our graph, right? So as long as we label this 0, 6, we can have the same shape. If you really want, you could make these lines have a little bit more significant slope, but this is just a sketch. As long as we have these labels there and everything's in the right relative position, we're okay. The last thing to do is to add the plus 2 at the end. So we have 2 times 3 minus x plus 2. Notice I went from x minus 3 to 3 minus x just so this form is the same one that we saw in the beginning. These two things are the same. Keep that in mind. So this plus 2 is a vertical shift. And since it's plus, it's a vertical shift upward. So now this point, which is at 3, 0, becomes a point at 3, 2. So we can draw the graph like this and like this. So this is now 3, 2. The y-intercept, which was 0, 6, is now shifted up by 2 units. So it is 0, 8. And there's a sketch of the graph.